Hello everyone, welcome to the study of linear difference equation of the first order with constant coefficient. Here we are looking at a case whereby the roots are real and distinct. We are going to consider this example and we are going to solve this by let our y to be equal to exponential mx. Then we find y prime. Y prime is the same as derivative of y with respect to x, which in this case, when we differentiate the exponential mx, it will give us m multiplied by exponential mx. Then you differentiate it twice. Y double prime is the same as d squared, or a second derivative of y with respect to x, which is equal to, now you have m times m will give you m squared exponential mx. Then from there, now you substitute your result on this ODE, where you have second derivative of m, you substitute it with this, and where you have first derivative, you substitute it with this, and where you have y, you substitute it with this other part here. So doing those three substitution, we are going to have m squared exponential mx plus 6m exponential mx plus 8 exponential mx is equal to 0. So we can factor here exponential mx to be left with m squared plus 6m plus 8. This will give you 0. Now, we know that exponential mx can never be equal to 0, meaning that the only alternative we are left with in this case, it is to have m squared plus 6m plus 8, which is equal to 0. This is a quadratic equation whereby we have our product as 8 and we have our sum as 6. So the factors of 8 is 4 and 2. So 4 times 2 is 8. 4 plus 2 is 6. So that is how what you are going to use to factorize. So you have m squared plus 2m plus 4m plus 8 is equal to 0. We have substituted 6 with the 2m and the 4m, which is the same. So m, we factor m here in the first two to be left with the m plus 2. We factor 4 in the other two part to be left with the m plus 2. This will give you 0. Now, we can factor m out, so you have m plus 4, m plus 2. This gives you 0. That means that m plus 2 is equal to 0, which tells you that m1 is -2. Also, m plus 4 is equal to 0, meaning that our m2 is equal to -4. So the linear combination of our solution will be given by this form: y is equal to c1 exponential m1x plus c2 exponential m2x, which is equal to c1 exponential -2x plus c2 exponential -4x. That is our solution of the given ODE. Our given ODE was y double prime plus 6y single prime plus 8y is equal to 0. So we can check whether our working makes sense or it is correct or not. Check. So we are going to use this fact that y is equal to c1 exponential negative 2x plus c2 exponential negative 4x. Then we are going to get y single prime, which is, we differentiate this, which will give you negative 2c1 exponential 2x minus 4 c2 exponential negative 4x. Then you get your y double prime. This one, it will become 4 c1 exponential negative 2x. Then you have plus 4 times 4 will give you 16 c2 exponential negative 4x. From there now, you substitute those two here in this equation. So you will have 4 c1 exponential negative 2x plus 16 c2 exponential negative 4x. Then you come to 6 and you substitute this the other one here. So you have 6 times 2, which will give you negative 12 c1 negative 12 c1 exponential negative 2x. Then you have 4 times 6, which will give you 4 times 6 will give you 24 because it is negative, so we write negative 24 c2 exponential negative 4x. Then you have the last one, 8 times the value of y, which is here. So you will have 8 c1 exponential negative 2x plus 8 c2 exponential negative 4x. This will give us what? So in group like term together, and then after grouping, we simplify. So that, let's do that. You have 4c1 exponential negative 2x. We check the other one, which is the same. You have that one, therefore you have 4. Then also you have negative 12. 4 minus negative 12 will give you negative 8. Negative 8 minus 8 will give you 0. So we are done with the one which you have c, plus you have 16c2 24, which can give you negative 8 c2, and this 8 here, which gives you 0, which is equal to 0, meaning that our working is correct. So the solution of this second order plus 8 is equal to 0. Our solution, we have obtained it as y is equal to c1 exponential negative 2x plus c2 exponential negative 4x. That is our correct working. And for further studies on linear difference equation of second order with the linear coefficient, you can check in my YouTube channel. Also, I'm going to provide the link below so that you may study other part together with me. So thanks so much. Remember to subscribe to the channel if you have not yet, so that you don't miss a single video which I upload for us every day. And bye bye. See you in the next presentation.